Third and final video for my Algebra 3 Prerequisite section number 1, in which we're going to be basically discussing the real number line and what we mean by absolute value, as well as simplifying expressions. So really quickly, let's recap the number line. Pretty simple here. In one dimension, we say the number line. One point we do want to label here is this, is basically 0. We refer to this as the origin, okay? But we say all positive values lie to the right, all negative values to the left, and we say that 0 is simply just non-negative, it's neutral, okay? So you'll notice that I have a number line here, and upon it we've got a bunch of rational as well as irrational numbers that have been graphed, okay? So for instance, -2 would be an easy point to graph because it falls directly on, say, an integer value. But -1/2, of course we could kind of determine it's halfway between 0 and -1, but a good way to figure that out would be to just put it into a calculator. So given any numbers, if you're ever confused as where they lie on the number line, the best thing you could do for yourself, so for instance 11/4 there, you notice I have 11/4 here, is to either reduce it and rewrite it as a mixed number like 2 and 3/4. So just to say 11 divided by 4, it's going to give you a good idea that it lies 2 and 3/4 of the way to 3 there, so 2.75. As well as with your rational numbers, we could say square root of 2. Square root of 2 is about 1.414-ish, and so we got the square root of 2 right here, but we're not going to label it 1.4-ish. We're going to label it with the square root of 2. It's exactly the square root of 2. The reason why I wanted to point this out really quickly is this. We say that every number, when graphed on the number line, has exactly one point that goes with it. So we say that there is a 1-to-1 correspondence. Okay, between every number and its graph of the graph of its point. Okay, so speaking of the number line, let's go ahead and visit what absolute value is. If you recall from probably 7th grade, we said the absolute value of a number A, we denote it with these vertical bars here, and they kind of act like parentheses, but they're not. And I want to point something out here. If you had the absolute value of, say, x minus 7, you had a 2 out front, it is not equal to the absolute value of 2x minus 14. The thing is, they act kind of like parentheses, but you cannot distribute through them. So what this absolute value is indicating is the distance, this inner quantity is from 0. So we say the distance from 0 to A on the number line, that's what the absolute value of a number is. So for instance, if I said, what's the absolute value of -3? Well, it's just 3, and the reason why is because if we go up here to this number line, we say, well, let's graph -3, and we find its distance back to 0. The thing is, we say that the distance is always non-negative. Distance is always kind of a non-negative quantity here. Okay, so we say -3. If I were to say, what's the absolute value of 0? How far away from 0 is 0? We say that it's 0 units away from itself. So we say that's 0. And then we would say that, 5, the absolute value of 5. If I were to graph 5, then this has a distance value of 5. So the absolute value of 5 would be equal to 5 units of distance. So what I would like to do is basically find the absolute value of the following expressions here, and we can certainly use a calculator. But what I want you to notice here is 1 minus the square root of 2. Well, the square root of 2 is about 1.414. So the thing here is that you would think that this is going to be negative in here. You get approximately the absolute value of negative 0.414. If I were to take 1 minus 0.414, I'd get about this right here. But the idea here is that I'm always going to get a non-negative value, so about 0.414. Whereas if I were to look at this here, we know that pi is roughly about 3.14159. So if we were to rewrite this, I notice that the inner quantity comes out to be positive, but the idea is that still, 3.14 minus 3 is going to be about 0.14. It's still going to come out to be 0.14, and I better put this right here, ish. Okay, it's an approximation. And then last but not least, we say if x is greater than 0, what would be true about this statement here? Basically, what you're going to come up with is 1, and I want you to think about this. Why does that happen? What if x was equal to 2? It's greater than 0. So we'd say, well, I got the absolute value of 2 over 2 itself. The bottom number, since the restriction on x is that it's always positive, is going to be positive. And what do we know about absolute value? Well, it always comes out to be positive. And likewise, anything divided by itself is 1. So I'm always going to end up with 1 for this expression. So remember, absolute value is just the distance from 0 to a given number on the number line. It's always non-negative, okay? So really quickly, we say the distance between 2 points on the real number line. A really quick way to do this is always say that if A and B are any 2 points on a number line, the distance between them, A and B, is given by this. So it's the absolute value of their differences. Okay, you could subtract in any order you want. It's always going to be the distance between these two numbers. So for instance, if I said, well, how far apart are -5 and 3 on the number line? Obviously, we say, -5. We go here, -5. Let's switch colors. -5 and positive 3, they're certainly 8 units apart. Okay, we got 5 and 3, and that's a total of 8 units. But basically, we're saying we could find this by saying, let's find their difference, the absolute value of their difference. Okay, so I could write it this way. I could say that, it's equivalent to say that this is also the same as 3 minus a negative 5. But if I find their differences here, in this case, I would get the absolute value of negative 8, which comes out to be the same thing as what this is going to be here, except for on the inside, I get positive 8. But remember, the absolute value is always going to come out to be non-negative. So we just say that this is 8 units apart. Of course, they're 8 units apart. Okay, so really quickly, let's talk about simplifying algebraic expressions. Often, what we mean when we say simplify an algebraic expression is that we've combined like terms and carried out any operations that needed to be done. So when you hear term, this is an important term, but we say the terms of an algebraic expression, these are the parts that are separated by addition, or you could say subtraction, kind of. We could rewrite it as addition, but this expression here has 4 terms, and we want to be using that terminology, okay? So we say like terms are any terms that have exactly the same variable factors, okay? So for instance, 3x and 7x, we say that these are like terms. So the distributive property, remember, if we had some quantity b plus c times a, we could distribute this a, we could right distribute, and what we get here is ba plus ca. But the point that I want to draw upon here is this, that this ba and the ca have the same variable a and the same power, a to the first. So we could say, well, then really I have b plus c of these a things, and we're just using the distributive property to do this. So of course 3x plus 7x is 10x, but the reason why we're getting this is because if you factor out the x, okay, you get 3 plus 7 times x, which is 10x. And likewise, if we said 7y minus y squared, an important thing to point out here is that the coefficient of this y squared is 1, so we get 6 total y squared. So let's go ahead and finish this video. We're going to go ahead and simplify these expressions here. We also say that simplification occurs when you've removed all parentheses. So looking at this, I'm going to start by distributing on both of my terms here. I have 2 terms separated by addition. But we say 7 times 4x squared is going to be 28x squared. And 7 times 3x is going to be 21x. Now I'm taking all of that, okay, all of that, plus 2 times 5x squared is 10x squared, and 2 times x here is positive 2x. And so when we add these together, combining like terms, I notice that the x squareds can go together, and I say, well, 28 plus 10 more of these x squareds gives me 38x squareds, and 21x's to the first plus 2 more x's to the first is going to give us 23x's to the first. And this would be a simplified expression because we've carried out all operations that can be carried out. There's no parentheses and we've combined like terms. This one over here, I do want to look at this. It's very important that we do because order of operations, at least, would indicate that we start at the innermost set of parentheses here. So we say x minus 2. Now there's nothing to do in here. However, I do want you to notice that I put in a negative 1. Often people forget that we could interpret this as being a negative 1 out front, but when you distribute that negative 1, let's rewrite this expression. I'm still going to have 6 plus 4 times and in brackets, but we say 7. And if I were to take negative 1 times x, I would say I get negative x. And if I were to take negative 1 times a negative 2, I actually get a positive 2. So one way to look at this is whenever you have a negative in front of a set of parentheses, what you could do is you could distribute the negative by making this a positive and then changing the signs of everything on the inside. You'll notice we get that negative x there and we get that positive 2 there. So finishing this up, we'll go ahead and distribute our 4. We get 6 plus 4 times 7 is 28. 4 times a negative x is going to be a negative 4x. 4 times a 2 is going to be 8. And with respect to like terms, we have a 6, a 28, and an 8 as constants. So 6 plus 28 is 34. 34 plus 8 more, it's going to give us 42. So I would say that it is most appropriate to write this, and I'm going to try to make this a little bit more clean. Negative 4x plus, and I believe we said 42, plus 42. And you'll notice that I put the x to the first term first. We tend to write the exponents in decreasing order, but that's how you simplify an expression.